Okay, now we will discuss the 4 mark questions. Uh, 21st question. It says the diagonal of a rectangular field is 16 meters more than the shorter side. If the longer side is 14 meters more than the shorter side, then find the lengths of the sides of a field. For this, first we need to draw a diagram. Let us suppose there is a diagonal, there is a rectangle, we see. Let this be a rectangle. Now draw a diagonal. Name the points as A, B, C, D. So A, B, C, D is a rectangle with AC as a diagonal. Now it says the diagonal of the rectangular field is 16 meters more than the shorter side. So let the shorter side be X. So diagonal will be X plus 16 because it says 16 meters more than the shorter side. If the longer side is 14 meters more than the shorter side, let the longer side be 14 meters more than the shorter, so it will be X plus 14. So in this case, shorter side will be BC, diagonal will be AC, and the longer side will be AB. Now in a rectangle, all the angles are 90 degrees. So consider this as a right angled triangle ABC. So in right triangle ABC, we have AB square plus BC square is equal to AC square. Now AB square will be nothing but X plus 14 the whole square plus BC square will be X square, which is the shorter side, and AC will be equal to X plus 16. Substituting the values, we get the equation X plus 14 the whole square plus X square is equal to X plus 16 the whole square. Now solving for X, for solving for X, first we need to expand it. Expand the expressions. So this will be X square plus 28X plus 196 plus X square is equal to X square plus 32X plus 256. So now rearranging the equation, we'll get X square minus 4X minus 60 is equal to 0. Now solving this quadratic equation, we get the factors as splitting the middle terms, we get X square minus 10X plus 4X minus 60, sorry, this will be 6X minus 60 equal to 0. So this will be x into x minus 10 plus 6 into x minus 10. So solving, we get x is equal to 10 and minus 6, but x equal to minus 6 will not be considered because the length of a rectangle cannot be a negative sign. So x is equal to 10 is the answer. So x equal to 10, so x being the shorter side will be equal to 10 meters. Now the diagonal will be x plus 16, which is equal to 10 plus 16, that is equal to 26 meters, and the longer side is given as x plus 14, that is equal to 10 plus 14, which is equal to 24 meters. So the sides, the length of the sides of a field will be longer side 24 meters and shorter side will be 10 meters and the diagonal being 26 meters. With this we can also calculate the area of the rectangle because we know the values of length and breadth, so as the perimeter by applying the formula. Next question. 22nd problem. See, the problem says find the 60th term of the AP 8, 10, 12, it goes on like that. If it has a total of 60 terms and hence find the sum of its last 10 terms. Okay. So the AP is given as 8, 10, 12 and it goes like this. So with this we can able to find the value of here. A will be equal to 8, which is the first term, and D will be equal to second term minus first term, that is equal to third term minus second term, and it goes like this. So the common difference will be equal to 2. Now A of n is equal to A plus n minus 1 into D. That is the formula for the nth term in an AP. So the 60th term will be A of 60 will be equal to A plus 60 minus 1 into D, which is nothing but A plus 59D. So that is substituting the values of A and D here, we get A equal to 8 plus 59 times 2. That is equal to 8 plus 59 times 2 will be 118. So the value of 60th term will be 126. Now they are asking the sum of its last 10 terms. Also the total of 60 terms. So sum of the last 10 terms can be written as A of 51 plus A of 52 plus A of 53 plus dot 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 plus till A dot 60. Now here the number of terms n will be equal to 10. First term here A will be equal to A of 51, which we can apply the formula A of n is equal to A plus n minus 1 into D. That is the nth term formula in an AP. So A of 51 can be written as A plus 51 minus 1 into D. That is nothing but A plus 50D. That is equal to substitute the value of A and D in this equation. We get A equal to 2 plus 50 times A equal to 8 and D will be equal to 2. Substituting the values in the equation A plus 50D, we get 8 plus 50 into 2, which is nothing but 108. Now we have already found out the last term L equal to A of 60, that is equal to 126. So the sum of last 10 terms can be written as n by 2 into A plus L. That is the first term and the last term. N will be equal to 10 by 2. A will be here will be A of 51, which we have found out 108, plus last term will be 126. So calculating, the answer will be equal to 1170. So the sum of last 10 terms will be equal to 1170, and the AP as given is 8, 10, 2 with the first term as 8 and the common difference as 2. Now let's go to the next question. Prove that the length of the tangents drawn from an external point to a circle are equal. Now let me draw a circle for you. Let it be a circle with center O, and let circle has a center O and radius equal to R. So let P be an external point where when produced meets the circle at points A and B. Where PA and PB be the tangents. Now we need to prove PA is equal to PB because it is given length of the tangents drawn from an external point are equal. So we need to prove PA is equal to PB. Now proof. In triangle OAP and triangle OPB, we have OA equal to OB being the radius of the circle, and angle OAP is equal to angle OBP because radius of a circle is perpendicular to tangent, and OP is equal to OP common side. So we have triangle OAP is congruent to triangle OPB. By SAS congruency. Hence, PA is equal to PB. So we can say that the lengths of the tangents drawn from an external point to a circle are equal. Now question number 24. A train travels at a certain average speed for a distance of 54 km and then travels a distance of 63 km at an average speed of 6 km per hour more than the first speed. If it takes 3 hours to complete the total journey, what is its first speed? Here, the general well-known formula we need to use is speed is equal to distance by time. This is the basic formula that we need to apply. However, it involves the concept of quadratic equation here. So, let the average speed of first train be x kilometer per hour. Now it says, now according to the condition, we have 54 kilometer and 63 kilometer are the two distances, and the second distance, the average speed is 6 kilometer are more than the first speed. So the first distance covered will be equal to 54 kilometers divided by x, which we have assumed, which we need to find, and the second distance is 63 kilometers, and it says that the average speed of 6 kilometer more than the first speed. So first speed we have assumed as x, so this will be x plus 6, and this is equal to 3 hours, because when speed is equal to distance by time, then time will be equal to distance by speed, because it says if it takes 3 hours to complete the total journey, so the to and fro journey totally it takes 3 hours. So solving the equation, we get 54 into x plus 6 plus 63x is equal to 3 into x plus 6. We are taking the LCM and then we are doing the cross multiplication. So expanding this, we get 54x plus 324 plus 63x is equal to 3x square plus 18x. So rearranging the equation, we get 3x square minus 99x minus 324 equal to 0. Dividing the equation by 3, we get x squared minus 33x minus 108 is equal to 0. Now splitting the middle terms, we get x squared minus 36x plus 3x minus 108 is equal to 0. Or we get x plus 3 into x minus 36. Now solving these equations, we get x is equal to minus 3 and 36, but speed cannot be negative, so x equal to 36 is the value. So the average first speed for first journey, which is 54 kilometers traveled by train, is equal to 36 kilometer per hour. Now we are moving to next question. Next question, 25th question, it says, prove that the tangent drawn at the midpoint of an arc of a circle is parallel to the chord joining the endpoints of the arc. Now let me draw the diagram for you, which is very important. Let it be a diagram, let it be the circle with center O and radius R. Okay. Let OA be equal to OC equal to radius of the circle. Let DE be the tangent intersecting the circle at B. Now it's given that AB arc AB is equal to arc BC. To prove, we need to prove that AC is parallel to DE. Proof. Since it is given B is the midpoint of arc of a circle, we have arc AB equal to arc BC. So, since midpoint B of arc ABC is given, we have angle 1 equal to angle 2, that is angle AOB is equal to angle COB. That is angle AOB is equal to angle COB. And angle OF is equal to angle OF, which is the common side. Also, OA is equal to OC, that is equal to radius, which I had already mentioned earlier in the problem. Here. So, angle AOF is congruent to angle COF by SAS congruency. So angle AFO is equal to angle CFO equal to 90 degrees, because AC is a straight line with two angles where AFO plus CFO is equal to 180 degrees, but if these two angles are equal, then each angle will be equal to 90 degrees. Because, and also the tangent is perpendicular. When OF is extended, it meets the point B, wherein OB will be the radius. Again, OB will be the radius, and radius is perpendicular to, which is perpendicular to the tangent. So this angle will be equal to this angle, and this will be equal to this angle. Angle DBO is equal to angle EVO. Also, angle AFO is equal to angle DBO. That is equal to 90 degree. Which also seems to be the corresponding angles. Hence, we can say AC is parallel to D. Question number 26 we are not discussing here because it is a construction problem, and I kindly request you to do it by yourself. Now let's go for 27th question. 27th question, it says at a point A 20 meters above the level of water in a lake, the angle of elevation of a cloud is 30 degrees. The angle of depression of the reflection of the cloud in the lake at A is 60 degrees. Find the distance of a cloud from A. Let me draw the diagram for you. Let it be the ground level, let it be the water, the lake. It says at point A, which is 20 meters above the level of water in the lake, the angle of elevation of the cloud is 30 degrees. So this angle will be 30 degrees. The angle of depression of the reflection of the lake cloud in the lake at A is 60 degrees. So this will be the angle of depression, and the reflection of DC will be equal to D. So from this point, at the point of reflection, the angle will be 60 degrees. Find the distance of the cloud from A. Let this distance AB be equal to X and BC being H, let it be H meters. So it is given that point A is about 20 meters. So this will be 20. So therefore AF will be equal to BD, which is also equal to 20 meters. Now we need to calculate the value of AC, that is the distance of the cloud from point A. Now given AF is equal to BD equal to 20 meters. Now we need to find AC. Now solution. In this diagram, you see in a right angled triangle ABC, which is right angled at B, we have tan 30 is equal to H by X, which is nothing but tan 30 is 1 by root 3. So 1 by root 3 is equal to H by X, which implies that H is root 3 of H is equal to X. Same way, in triangle ABE, ABE, we have tan 60 equal to BE by AB. Now BE can be written as BD plus D, that is equal by AB. But DE is equal to DC, which is the reflection. So, but DC is equal to DB plus BC, which is given by DB is nothing but BD, which is 20, and BC, which you have assumed as H. So it will be 20 plus H. So substituting the values of BD, D and AB in the equation, we get tan 60 is equal to H plus 20 divided by X. So tan 60 is root 3. So root 3 will be equal to H plus 40 by X, or root 3x is equal to H plus 40. But X is equal to root 3H from equation 1. Substituting in this equation 2, we get root 3 into root 3 of h is equal to h plus 40, or 3h is equal to h plus 40, or 2h is equal to 40, which implies h is equal to 20 meters. Now in the right triangle ABC, we have AC square is equal to AB square plus BC square. So AB is nothing but x, but x is root 3h. So root 3 into 20. So which is 20 root 3, the whole square, plus BC is 20 square. So solving, we get AC is equal to 20 into 2, which is 40 meters. So the distance of a cloud from point A, which is AC, according to this diagram, is 40 meters. Now let's go to 28th problem. 28. 28 is a probability problem. A card is shuffled at random from a well-shuffled deck of playing cards. Find the probability that the card drawn is a card of spade or an ace, a black king, neither a jack nor a king, either a king or a queen. Now, in the deck of cards, a deck has 52 cards with 4 groups being spade, clubs, hearts and diamonds. 13 cards each. Now the normal cards will be A 1, 2 up to 10, and the face cards will be king, queen and jack. So each group will have 10 normal cards and 3 face cards. Now let's deal with the first part of the problem. The first problem says probability of drawing a card of spade or an ace. Now ace, there are 4 ace, and spades, it has 13, but probability of drawing a card of spade is nothing but 13 by 52, plus probability of drawing a ace in the deck will be 4 by 52, but we have already included one ace of spade in the previous thing, so we need to include the remaining 3 ace, which is 3 by 52. So it will be 16 by 52, which is 4 by 13. So first part of the problem is done. Now second part. A black king. There are actually 4 kings because there are 4 groups, there will be 4 face cards. But when it comes to black, spade and clubs are black in color. Hearts and diamonds are red in color, red color. So a black king will have black king. So king, it's four kings and black card. So black will have two kings. So probability of a black king will be 2 by 52. When simplified, it becomes 1 by 26. 3. Neither a jack nor a king. It's given neither. So we need to exclude that. There are 4 jacks and there are 4 kings. That makes it 8. So probability of neither jack nor king will be equal to 52 minus 18 by 52. That is equal to 44 by 52. When simplified, it becomes 11 by 13. Fourth problem says either a king or a queen. King, it has 4 and queen, it has 4. So it says either or. So we need to include both. So probability of getting either a king or a queen is equal to 4 by 52 plus 4 by 52, which is nothing but 8 by 52. When simplified, it becomes 2 by 13. Now, next problem, 29th. Find the values of k so that the area of a triangle with vertices 1, minus 1, minus 4, 2k and minus k, minus 5 is 24 units. Now, in this problem, we need to find the value of k for that, so that the points that is given has a total area of 24 square units. Now we need to apply the area of a triangle formula in coordinate geometry. Now generally area of a triangle will be half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Let the points be equal to a 1, 1, b minus 4, 2k and c minus k, minus 5. So now here this will be x1, y1, x2, y2 and x3, y3. And it is also given that area of triangle ABC is equal to 24 square units. So substituting the values, we get half into x1 is 1 and y2 minus y3. y2 is 2k and y3 minus of minus, it will be plus. So it will be 2k plus 5. x2 minus 4 into y3 minus y1. y3 is minus 5 and y1 is minus 1. So minus of minus will become plus. And plus x3. x3 is minus k and y1 minus y2. y1 is minus 1 and y2 is minus 2k. This is equal to 24. Now we need to solve the value for k. So the 1 into 2k plus 1 will be 2k plus 1. This will be minus 4 into minus 4, and this will be minus k into minus 1 minus 2k, that is equal to 24 into 2, which is equal to 48, or 2k plus 5 plus 16 plus k plus 2k square is equal to 48. Or we have, rearranging the equation, we have 2k square plus 3k minus 27 is equal to 0, or 2k square, by splitting the middle terms we get 9k minus 6k minus 27 equal to 0, because product will be minus 54 and the sum will be equal to plus 3. So solving the value of k, we get 2k into k minus 3 plus 9 into k minus 3 is equal to 0, or 2k plus 9 into k minus 3 is equal to 0, which implies that 2k plus 9 equal to 0, or 2k equal to minus 9, or k is equal to minus 9 by 2, or k minus 3 is equal to 0, or k is equal to 3. So these are the two values for which the given points has an area of 24 square units. Now let's go to next problem, which is problem 30. The problem says in figure 5, PQRS is a square lawn with a side PQ equal to 42 meters. Two circular flower beds are drawn on the sides PS and QR with center O, the interaction of the diagonals. Find the total area of the two flower beds, which is the shaded portion. So we need to find the shaded portions, which is also given as flower beds. Now let us assume the radius of circle with center O is equal to OR, which is equal to X. Now the diagonals of a square bisect each other at 90 degrees. So if this is X, this will also be equal to X. We need to find the value of RQ. So in the triangle ROQ, we have x square plus x square is equal to 42 square. RQ is nothing but the side of the square, which is given as 42. It is given PQ is 42, but it's a square. So this will be 42, this will be 42, this will be 42, and this will be 42. So x square plus x square is equal to 42 square, or 2x square is equal to 42 square, or x will be equal to 21 root 2 meters. Now area of one flower bed is equal to area of the segment with center angle 90 degrees, that is this one, minus area of the triangle ROQ. Now we have area of the segment with the center angle 90 degrees is given by pi r square theta by 360 minus half of OR into OQ, half into base into height. So that is equal to 22 by 7 into radius being 22 root 2 into 21 root 2 into 21 root 2 into 90 by 360 minus half into 21 root 2 into 21 root 2, that is equal to, if we calculate this value, this will be equal to 693 minus this value will be equal to 441, which is equal to 252 meter square. But this is the value of just one flower bed, so we need the value of two flower beds. So the total area will be equal to area of two flower beds, that is equal to 2 into area of one flower bed, which is 252, that is found here. So the answer will be equal to 504 meter square. So the area of the shaded portion, or we can say the total area of the two flower beds, will be equal to 504 meter square. Now we are moving to the last problem of the 4 mark. It says, from each end of a solid metal cylinder, metal was scooped out in hemispherical form of same diameter. The height of the cylinder is 10 cm and its base is of radius 4.2 cm. The rest of the cylinder is melted and converted into a cylindrical wire of 1.4 cm thickness. Find the length of the wire. First, let us draw the diagram for this. So this will be the hemispherical part that has been scooped out. So height of the cylinder is given as 10 centimeter and the radius is given as 4.2 centimeter. Now it says the metal was scooped out in a hemispherical form of same diameter. Now this forms two hemispheres. The height of the cylinder is 10 cm and its base radius is 4.2 cm. Rest of the cylinder is melted and it is converted into a cylindrical wire of 1.4 thickness. Now we need to find the length of the wire. Now the volume of the remaining part is actually converted melted and converted into a cylindrical wire. So the volume of the remaining part will be equal to the volume of the cylindrical wire. First we need to find the value of the volume, total volume of the cylinder. Total volume of the cylinder is given by the formula pi r square h, that is equal to 22 by 7 into 42 by 10. I am converting the centimeter, removing the decimals. 4.2 I am writing is 42 by 10 into 42 by 10 into height 10. So the answer will be 554.4 centimeter cube if you calculate. Now we need to calculate the volume of the metal that is scooped out. That is equal to 2 times the volume of the hemisphere. Volume of the hemisphere is nothing but 2 by 3 pi r cube. So that will be equal to 2 into 2 by 3 into pi 22 by 7 into r 42 by 10 the whole cube. If we calculate that, it will be 310.46 centimeter cube. So the volume of the remaining part is equal to volume of the cylinder minus the volume of the metal that was scooped out. So it will be 554.4 minus 310.46, which is equal to 243.94 centimeter cube. Now this volume of the remaining part is actually nothing but the volume of the cylindrical wire. Now this volume of the remaining part is equal to the volume of the cylindrical wire that has been recasted. Again, the volume of the cylindrical wire can be written as pi r square h. Or it can also be written as pi r square L, where L being the length of the cylindrical wire which we need to find out, and R of the cylindrical wire is given as 1.4 centimeter thickness. So thickness is 1.4 centimeter, that is equal to diameter equal to 1.4 centimeter. So radius will be diameter by 2, which is 1.4 by 2, which is 0.7 centimeter. So that can be written as 22 by 7 into r square, which is 7 by 10 into 7 by 10 into L, is equal to volume of the remaining part, which we have already found out, which is found to be 243.94. So solving for L, we get 243.94 into 7 into 10 into 10 divided by 22 into 7 into 7. So solving we get 158.4 centimeter. So the length of the cylindrical wire after it is recasted from the remaining part will be 158.4 centimeter.